Besides that, what we cover today is not fair game for the quiz tomorrow. We'll not include this on your quiz, but we do need to move on. We're getting behind. Mr. Hall's tired of being behind, and we cannot fail in chemistry. Today, we're going to take a journey. Our journey takes off from here. It's like, this is when I start getting really, really excited. Because we're getting to some real deal chemistry now. Today,
You say that for every one of the new lessons.
I know, right? Well, at least I don't look at you and say, I'm dreading this. This is awful. This is just awful.
Well, if you're really dreading it, then you should just be honest.
I'm not dreading it. I look forward to all of it.
I wonder if I'm still that I was lying or not.
Today, we start chemical reactions.
What day is today? The 24th?
About what?
Nobody knows what day it is.
So, chemical reactions, this is the one where, I'm just going to go ahead and tell you, this is where everything really starts coming together. We just left nomenclature. Do you think we're ever done with nomenclature?
Probably never.
No, you're going to see nomenclature in here. There's a bunch of rules that go within chemical reactions that makes it complex. But you can do this. Mr. Hall believes in you. You will accomplish it. You will master it. You will destroy it. It will cry for its chemistry mama. Okay? So chemical reactions. Whenever you look at chemical reaction, I'm going to give you a definition of it. Now, my definition, as you're used to, Mr. Hall's definition is not something you will ever find in a textbook or something that Google would give you. This is something to where I want you to have an understanding of really what's taking place. Who cares if you can recite some stupid Google definition to me if you don't know what it means? Chemical reaction is you take some stuff that stuff, what we like to call like molecules or compounds,
Is that a slash?
yes,
It kind of looks like a parenthesis. Thank you.
and mix it with some other stuff and that stuff turns into new stuff. You didn't start with. So I know it's a whole lot of stuff. We're talking about a bunch of stuff. But this is what I want you to get. We're taking things, we're mixing them together, and once we mix them together, some things we'll have to add stuff in, other things we won't. Whenever we throw this stuff together, that will turn into new stuff we didn't start with. That's the whole premise of chemical reaction taking place. And whenever you look at this, and you break down a chemical reaction, you have something that I like to start right off the bat with. It's a chemical equation. So, what you got up here, I know it may look very confusing to you. Don't worry, you'll see plenty of them. Pretty much all I've put up here are just in this is just letters or fillers or just variables, okay? All they are. When you look at these, the small letters equal numbers. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't care, just digits. Then from there, your big letters. Big letters. Are equal to molecules or compounds. So this thing can literally be all that nomenclature and stuff you've learned. That's what goes there at those big letters. So chemical formulas for those that are sitting in there, things that you're starting with. Whenever you break this down, you have certain things that this tells you. Hopefully you're familiar with this. You may not be, and if you're not, that's okay. Mr. Hall's not mad. If you had me for biology, we did hit this right out the gate. The left side of the chemical equation is what we call reactants. You have the arrow. And the reactants go to the right side, which are our products. The arrow over the middle just stands for yields. Do what?
I know this was Robert did. Eagles. I think it's hilarious.
So your left side, your reactant, this is how I like to look at it. Your reactants are what you start with that will react to yield to the products. Products are what we're trying to produce. It's what we're ending up with. It's what we're looking at the end. So whenever you look at these, you're going to see something. You can actually determine and know if a reaction takes place. Let me check something. I forgot to restock.
What exactly were you looking for?
A glow stick.
You had glow sticks this whole time?
No, I'm out. I forgot to restock. I'm not going to make him order. So what you're looking at is you can look and know we have indication of the chemical reaction. And you're going to see me start abbreviating reaction RXN just because I ain't writing all that down. I'm just telling you. I'm going to get tired of writing reaction. So RXN stands for reaction. So you have 3 different indicators that a reaction is taking place. Your first indicator is one you all are familiar with, especially right now. Is a release of heat or light. So this one, for example, when you're looking at the release of heat or light that's coming off, excuse me, sorry. Perfect example of this. Right now, tonight to be a perfect example. It's going to be really cold out. Softball players and baseball players are all going to be crying for one thing. They want some hot hands, hand warmers, something. So the whole thing, how does it work? You smack them, shake them together, and then what happens? Releases off heat. The whole premise of what's happening with that is you have two chemicals, your reactants, that are separated apart. When you break it and you shake them together, they mix together and then they give you a reaction and they release off the heat. This is where I like to pull out a glow stick and show everybody, just because I don't care how old you are. Glow sticks are cool. I said it, cool. Not ashamed. Don't care. I'll be a 80-year-old man in a nursing home and somebody will bring out a glow stick and I'll be like, man, this is so cool. Glow stick's a perfect example. What you'll actually see with a glow stick, if you would actually cut it open, there's a capsule in there that has another liquid. Whenever you break the stick and you hear that cracking and breaking, you're breaking the capsule. When you break the capsule out and you shake the stuff together, the two liquids mix and it releases off the light. The very pretty light. It's like magic every time. It's incredible. It's like, look, no light, light. Oh, pretty.
They're just not broad enough though.
True.
They handed me that at a haunted house one time through the big trail, and they said, "This is going to be your light for the whole way through." Yeah, like midnight through a forest. But I want to get through.
You're having to
So hot hand's an example of heat, and for light, glow stick. Y'all can go out here and tell everybody that I'm still a kid at heart, that I enjoy a glow stick.
No, we don't have to do that.
Cool.
What about that light thing you got in there?
I like that.
Make your plasma light.
Yeah. Does that not work?
Neon lights.
All that.
Yeah, you could show us that just because
We didn't get to really see that last time either.
Yeah, we didn't see it. We got called out.
We done like 30.
Yeah.
We got called
You
out.
guys see it.
Yeah, we go get it.
No.
Wow.
That is not a chemical reaction.
Yeah.
That's an exciting of the electrons and it drops that down.
We need a review.
Do we ever review in chemistry?
Yeah.
No.
All's
we
fair
need it.
game. We need to learn it back from. Never mind, I can't come up with nothing else.
No. If you want a review, it's on YouTube.
But that's
I'm happy on there.
Number 2, indicator that you have a chemical reaction.
Hey, I followed you. You on YouTube. That's what I did on my certification.
Production of a gas.
We're out of nuggets.
Now, I know what you all are thinking. Yes, people farting is a great example of a production of a gas. That's a lot of chemical reactions. Some are stinky, some are not. The silent ones are the worst ones.
Every time someone says the thing ninjas, no, it's right. Silent.
What do you
I'm not going to ruin so many things that you guys have learned.
What is he about to do? Besides what he was about to
Alright, so perfect example of this.
Is that going to be smelly?
Huh?
Is that going to be smelly?
No! I was talking about farting earlier. Wow. The water's just so clear.
What the?
You gotta give it a moment, let it clear out.
That's like McDonald's water.
Now I know not to get water at McDee's anymore.
Yeah, don't
It's so greasy, like when it comes out of the tap.
It's the dishwater.
It's like greasy.
Alright. Alright, hold on.
$8.69.
I got desperate because.
What did you, what?
Honey, I don't know who was working on that, but somebody made the worst decision.
I can't eat
It was burnt.
Alright, so in the beaker I just put water. In my hand, I have something that's very common to you.
Is that the
All of you, yeah, this is distilled. Every one of you have seen what's in my hand before.
A beaker.
Diego Mendoza reports at 1034.
Here's an indication.
Alka-Seltzer.
It's Alka-Seltzer. You see the bubbles forming? Guess what that is? It's a gas. This right now, I hold in my hand is a chemical reaction. It's very bubbly.
I was hoping you were gonna make something blow up.
That comes later. We will make things go boom.
That's what I was so excited for.
Yeah, but I done told you that if it does not take off the tile.
Don't worry.
Do that other time.
We are not talking about blowing anything up, YouTube.
What'd you say, Charlotte?
What did you say?
You're going to get me canceled. So, Alka-Seltzer is a perfect example. The fizzing, the bubbling, the production of gas is taking place. Whenever that's happening,
Don't believe that's there. John will break it.
I'll move it before John gets in here. It's a great indicator that something is taking place. Now, on the third one, I don't have a demonstration set up for you, but there will be a demonstration later on this third thing. The third indicator, you have a reaction taking place. This is the one that is interesting.
Or we could use the cat and the bomb to be one of our.
No.
Why? I could read the cat.
Third indicator, formation. Of a, make sure I get this right.
Tell me if he says rock.
That's good joke. No. Okay.
Precipitation.
Precipitation.
I was close.
I get it right. Yeah, precipitate. That is spelled right. So precipitate. I know you've probably never heard of, how many of you have heard of precipitate before?
I think rain would count as that.
That's precipitation.
So, precipitate is very simple. I'm going to put it in my terms so you'll get it. Formation of precipitant is a huge indicator that you had a chemical reaction. So precipitants is when a solid forms from two liquids. So this is a really cool thing, is I can take two liquids that are clear. I can mix them together out of nowhere. You can turn murky, cloudy, you can get different colors and things. Because what happens is the two liquids that look clear were actually solutions that had molecules in them that whenever they react, they trade out places, and we get a precipitant that forms out.
Like epoxy.
I don't have that set up for you, but we will be looking at that later on.
Or resin.
What's that stuff? Yeah, that.
Okay.
What do you consider that? What would that be considered?
Yeah, what would that stuff be considered?
What?
Bootleg.
Oh,
What?
that's cool.
It's 2 parts cornstarch, 1 part water.
Oh, you're talking,
And I can punch it.
And it's
like
like-
yeah, it stays solid, but if you just like,
Yeah.
if you apply force to it, it's solid, but if not, it's liquid. Yeah, I know what you're talking
I
about.
done that one time.
That's a mixture.
It's like, it's a special type of fluid, is what they call it. I can't remember the name off the top of my head. What?
Is Jello solid or liquid?
Mrs. Morgan needs to see the senior class officers and the senior student council in her classroom at this time. That's Cheryl Morgan.
Well, it depends. What's the temperature?
Room temperature. sort of temperature.
This room is cold.
Has it already been?
Can you shake it and it jiggles, or is it still a liquid? That's how.
It does both.
Has it set up yet? You've cut into it with a middle spoon, so now there's a little liquid on it while it also.
You know what this is? This is doors or wheels question right here. Is it a liquid
There's
or is it
obviously
something?
wheels.
There's
Jeopardy
obviously
for all
more
the money
doors
gets
than
their
there
own.
used to be.
No.
guy, but then I weren't.
I was always a wheel guy, and someone tried to convince me, like, that kind of makes sense, but
How
the
could
more I
there
thought
be-
about it,
100%.
it's always been wheels.
How could there be more wheels than there is doors?
All right, anyway, we're not in philosophy class. So here's where things come into play within chemical reactions that you guys are going to love. You have word or formula equation.
Fact or fiction?
Word. The word equation that you deal with. You're going to like this one. This is where the tricks come in. This is where it gets real deal. So whenever you got the word equation,
Everybody's heard about the word.
what a bird is a word. Perfect example of a word equation. This is where it becomes so much fun for Mr. Hall. Everything starts coming together. This is why I get so excited. Let's say I take hydrogen.
I would say something, but I can't, or else you can. I'll say it after I get rid of it.
And oxygen.
I won't.
Add some heat. That little triangle over the arrow just is enthalpy. It's adding heat. That's all I'm saying. And if I do this, we make it no water.
Sure.
No. Water. That's the word equation. Here's where things gets difficult. You just gotta love my honesty, right? I no longer have to give you the chemical formulas. Why? You know nomenclature.
Sure.
So you can do the word equation and take me to the formula equation.
No, I can help.
Can we though?
I don't know.
Because
Well,
I don't know what to do. I can't go home, or else I'll be like,
So a perfect example is, let's take this word equation and let's go to the formula equation. Whenever you're going to the formula equation, you will be using the chemical formulas. So what is the chemical formula for hydrogen?
just go sit at me, Charles.
That's why you're going to mess up. Hydrogen is
We told you we didn't know it.
H2 because hydrogen is a diatomic.
You'd think I'd know that because I'm the one who always screws Eliza for it.
What's the chemical formula for oxygen?
O2.
Why is it O2?
It's a diatomic.
Because it's a diatomic. It's by itself. Now this is going to react with some heat to form water. Now what's water?
H2O.
Which is also known as dihydrogen monoxide.
Yeah.
Now here comes the fun part. There's a special set of circumstances in law that comes to chemical equations. They have to be balanced. Law of conservation of mass states mass of the reactants is equal to the mass of the products. Mass of the products is equal to the mass of reactants. Therefore, however many hydrogens I have on the reactant side, I have to have on the product side. However many oxygens I have on the product side has to be what's on the reactant side. So you have to balance these. This is where something to get simple that later on I will show you how to do, but it's pretty much simple. I set up my chemicals, my elements that are there, and I count how many are there. How many hydrogens are on the reactant side? How many oxygens on the reactant side? So 2 for both. But then when I go to the product side, how many hydrogens?
2.
How many oxygens?
1.
So we got a problem. I'm not even. I don't have the same number of oxygens on both sides, so I have to fix it. This is where you fix it at. We can change the small letters in the front. I can put numbers here. I cannot put numbers in here. Do not change the chemical formula. If you change the chemical formula, you have a different molecule or compound, and that's a problem. If I put a 2 here, there's a difference between you hydrating and puking your guts out.
That's HO.
This is H2O2. This is hydrogen peroxide. If you try to drink hydrogen peroxide, be near a trash can. You're going to empty your stomach.
We test that.
No.
Why? We can have a test them.
Somebody do it.
Now, I need 2 oxygens. How do I fix it? I have to stick a 2 in front of the molecule. Whenever I do that, here's the thing. It changes the number of hydrogens as well. How many hydrogens I got now? There's 2 per molecule, and I have 2 molecules. So that's 2 times 2 is 4. How many oxygens? 2. Now fix the oxygens. Now I got a problem with the hydrogens. The hydrogens are off. How am I going to fix it? 2 right in front of it. Now, I just changed the hydrogens. I have 4 hydrogens.
I'm so proud.
That's balanced. I'll tell you somebody that actually likes doing this is Miss Rhonda Cole. Anytime I print them off, she grabs them. Hey, study, study, study. You can do this.
I'm bowing myself away for that stage.
So we've been talking about chemical reactions. We've been talking about, we spent one day with it. So today, I'm going to do something a little out of order compared to how I normally do, but I think it'll be more beneficial to me. So there's like a golden rule when it comes to chemical reactions. And I kind of already mentioned this to you. There is this law. You guys have seen this law and used its idea. Law of conservation of mass. Law of conservation of mass, in quite simple terms, states that mass of products is equal to the mass of reactants. All this is a big fancy way of saying however many elements you have on one side will be the same on the other side. I kind of introduced this idea to you whenever I talked about, when we did that one, just talking about taking hydrogen gas, oxygen gas, mixing them together with some heat, and we would create water. We had to balance it out because we started with, we didn't have the same number of oxygens on each side. And whenever we fixed the oxygens, then we had to go back and then fix the hydrogens. So that's kind of the same premise and idea doing here. So I want to introduce to you kind of my little rules to how we're going to balance equations. I want to introduce this because we're getting ready to get into the equations. And then whenever we start getting into the 5 types of reactions in those equations, we start working examples, I want to be able to balance them with you. So I will look at you and tell you, you will have what will probably be either your most loved worksheet that I'll leave you while I'm gone, or your most hated one, or be a worksheet on you balancing out chemical reactions. My voice is struggling today.
Take a cough drop.
I have one. It's not a bad idea. No, it's hard to understand me. So, let's talk about balance and reactions. Bless you.
Bless you.
Bless you. As of right now, I'm going to give you like 3 basic rules. So, first thing is you'll have to write the reaction with the chemical formulas. I know what you're thinking. Well, why'd you put that up there? That seems pretty obvious. I want to take this moment to stress to you. Mr. Hall is going to give you words of things reacting together. And you have to produce chemical formulas. So if we're still struggling with nomenclature, Mr. Hall is here to help you, but you need to come see Mr. Hall, okay? Okay. Okay. Very nice. Pretty good talk. After you've done this, you've got the proper one, then whenever we're balancing. Before I do this, I want to remind you, do not change the small subscript numbers. Only add large numbers in front of the formula. What I'm saying with that, H2O, I need 2 oxygen. If I go to that, that no longer is water. That is now hydrogen peroxide. You cannot change the little small subscript numbers. If you do that, it changes the molecule. It changes the compound. I can't stick the 2 in front of there, and I still have water. This works out perfectly. But Mr. Hall also get back on his soapbox for one moment and stress to you the importance of being able to do this properly. The reason this matters so much is this little thing that we call stoichiometry. Stoichiometry is based off of mole ratios. That's what these big numbers in the front's going to be. So if we can't get the big numbers in the front right, we can't do stoichiometry right. Back to that thing that Mr. Hall said, that it all comes back together. Which I had one of my former chemistry kids texting me yesterday, or 2 days ago. You weren't kidding. It all connects back together. Oh my gosh, this guy, no, Kevin, no. You weren't lying. It all connects back together. And it's like, he like did this for like 9 texts in a row, and I'm like, what are you talking about? So then he tells me where he's at and everything, and how it's connecting together, and I'm like, good God. So be encouraged, Mr. Hall's not lying to you. Step 1, we will balance atoms that occur only once on each side. Step two. Step two will be your favorite. Balance polyatomic ions together as a whole. Which is saying actually balance the polyatomic ion. Don't try and break it apart. So what step two is saying is like if I have carbonate, well, calcium carbonate, let's do that. What it's saying is how I did water the other day and I broke it down as calcium and carbon and oxygen. Don't do this. Actually leave carbonate together as a whole. It'll work out and balance a whole lot faster for you than trying to break the polyatomic ions up. 3. This is a big one. Trust me on this. You're going to want to save these guys for last. And this is the order and how you're normally going to want to balance them. Balance. Hydrogen. And oxygen. Last. Now, if you follow these rules, it'll work a whole lot better for you. But I'm going to tell you, not 100% of the time when you follow these 3 rules does number 3 work out for you. You may have to go back and tweak a couple things. Just telling you straight up. Okay? Any questions? Everybody's so bright-eyed, bushy-tailed this morning. All right. So let's talk about the 5 basic chemical reactions. Now, I'm going to introduce these 5 to you today, and then what we'll do is we will go more in depth in each one of them. I will look at you and tell you, each one of these have very specific rules that go along with them. And some of them are a whole lot more in depth. Okay? So the first one we're going to talk about are synthesis reactions. Second one is decomposition reactions.
Decomposition, like decomposing of a dead body?
Kind of that idea, but the decomposing of a dead body is a whole lot more complex than that. We're staying very basic, okay? Number 3. Put a little star next to 3. 3 is going to probably be your easiest one, but because it's so easy, kids normally get tripped up by it. I literally have to give you another piece of information. Mr. Hall gives you another gift for your quiz. So you know how you've always begged for other things on your quizzes? Mr. Hall's going to have to give you something for what we call single replacement reactions. Number 3 and number 4 is when things come into interesting things. Especially dealing with high school students, I always like to relate chemical reactions back to relationships. And I bring that up now so that we can have the conversation. Whenever Mr. Hall is speaking of relationships, we do not name names, we do not point people out. And for whatever dumb, stupid reason, whenever Mr. Hall gets to this, normally this craziness happens in the high school relationship world to where people come in and it's like, I start talking about something and I had no idea that this recently happened at Westside, and then everyone's like, stop. Just don't, okay? Don't talk about high school drama in my room. Save it for the hallway.
Yes, sir.
Save the drama for your mama. Number 4 is the double replacement. Can't wait for next week when we get to that. Number 5 is my personal all-time favorite. Most of the guys in the room will agree. Combustion. What is that? Oh, thank you.
Looks like a lot of wasted paper on that.
A lot of space. Second page, we got a lot more.
Comes back so there too.
And the third one's information I need. Okay. Combustion reactions. Combustion reactions are exactly what you're thinking of. Explosions, fire, things burning. You know, it's what plankton's favorite reaction as well. You know. Okay. No SpongeBob reference today? Nothing for nobody?
No, it's not really.
So let's start on. So we're going to start with the synthesis reaction, and I do this. I know it looks like, why in the world did I waste that time? I'll let you know, like, this is the order we're going to go in. I will look at you and tell you that
Basically a textbook.
right, look, the first 2 have a lot to go with it. Okay, just telling you straight up right now. There's a lot. You're going to feel overwhelmed as much as we're going to cover on the first 2. I promise you though, after the first 2, we get down here, it eases up. So we're kind of doing the belly of the beast here, and then it'll ease up, especially in this one, because then we get to make explosions and fires, and it's just great. It's wonderful. So let's start with synthesis reactions. So first thing you gotta know with synthesis reaction is what it actually is. And this is where Mr. Hall is probably a little too honest with his classes when I tell you stuff. I went all the way through high school and halfway through college using the word synthesis reaction, talking about synthesis reactions, and one day I finally went, you know, I really do not know anything whatsoever what a synthesis really means. Like, what's that word really mean? I looked it up. Different thing, but yeah.
Basically one thing becoming another.
Synthesis reactions,
Like synthetic.
combining. Combine 2 or more things together to make a new thing. Pretty much that simple. We're taking some things, mix them together, make a new thing. That's what synthesis is. Now, if you ever hear, like, let's say you watch some movie or something, I need to go synthesize, blah, 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 blah. Now you know what it means. So now you can be like all smart to everyone that you went and watched the movie with. Like, I know what they're talking about. So there's a general formula for this. You have substance A and substance X will yield to make substance AX. Very simplistic. Now let's go from simplistic, let's go through some rules. This is where stuff gets hard. This is why I encourage you to shake yourself. You need to stand up, pinch yourself, that's fine. If you need someone to Will Smith you, go right ahead. Me too.
What do you mean Will Smith you?
Will Smith slapped Chris Rock. Yeah.
He punched him. They've never seen him punch in their entire
We
life.
didn't know they watched the Oscars, we just watched the Facebook video.
Yeah. Don't look up the video because Will Smith uses some choice language that is not appropriate or good.
Well, you can watch him slapping because he doesn't use the language until the end.
Yeah, whenever he goes and sits back down, turn it off. Well, no, Chris Rock does. I was like, wow. Wow. All right, anyway, so synthesis reactions. Here's the key, okay, the key words that come in here. Elements. With oxygen. So here's the first set. So here's what you'll see coming first. Combining most sorry. I'm struggling this morning. My allergies out of whack, my nosebleeds have started. I hate this time. And it leads to pre-spawn. If you have no idea what I'm talking about, I'm a big time smallmouth wade fisherman. I love pre-spawn. I mean, you can throw a bear hook out there and fish will eat it. It's a beautiful time of the year. All right. Combining oxygen with elements. So combining most elements with oxygen forms oxides. A good example of this is like metals. So we can take, okay. So we can take most metals with oxygen and it's going to go to a metal oxide. So good examples, okay? I'd like to throw out some examples here. But sometimes this is like, sometimes this will happen. We will get some exceptions eventually, just letting you know. Let's say, for example, we have magnesium. We mix it with oxygen. So magnesium add it with oxygen. Yields to. Now this is where I want to start telling you how I'm going to introduce stuff to you. This is a perfect example of a question I could ask you. But I have to tell you a key piece of information. What type of reaction is it? So I look at you and I tell you this is a synthesis reaction. So we have magnesium and oxygen. So this is where you have to start applying the rules. Magnesium and oxygen. Well, we know what magnesium is. It's a metal. Forms with oxygen will form a metal oxide. What metal do you think is going to be used? Yeah, magnesium, the metal you start with, so it's magnesium oxide. That's the word formula. You ever think Mr. Hall's going to ask you for the word formula? Probably not. Very, very, very rare occasion I ever will. I'm going to ask you for this. Magnesium, Mg, plus oxygen is what? O2. Which goes to magnesium oxide. So now guess what we have to do? We have to use our nomenclature skills to get magnesium oxide right. So whenever you look at it, Mg, what's the charge on the magnesium? In the second column. Atomic number 12, positive 2, thank you. Oxide comes from oxygen, what's the charge on it? Negative 2. So we cross them. So it's Mg2O2, but that simplifies out because I can factor a 2 out. So it's just MgO. Am I done? No, because it's not balanced. Look at it. Mg, magnesium, oxygen. How many magnesiums on the reactant side? How many oxygens on the reactant side? Magnesiums on the product side? Oxygens on the product side. Well, we got a problem. Magnesiums are balanced, but the oxygens aren't. So everything's balanced right now except for the oxygen, so I got to balance the oxygen. So how am I going to do that? Big 2 here? Why no here?
Because that changes it.
That changes it. But if I put it here, is that okay?
Yeah.
Okay, now here's the key. I put the number in it. Do this for me. Don't skip this step. Look behind the number. Magnesium, we changed it. Oxygen, we changed it. A lot of people are going to look and say, okay, we got 2 oxygens now. Well, you also got 2 magnesium and 2 oxygens. Don't miss that step. If there's an element behind that, you change the number you have of it. Now I got a new problem. Now my magnesiums ain't balanced. Now I'm going to balance that. Done. That's the type of stuff I'm going to be looking at you and expecting you to do. Okay? You guys doing okay today? Mr. Hall's worried about y'all. Being very quiet.